So let's go through some examples of going between condensed structures, expanded structures, and skeletal structures. So my favorite version of these by far is the skeletal structure. And if you look at what's drawn here and you're trying to figure out what exactly do I have and where am I going? Well, so what I would say is if you put a dot at the end of each line or where two or more lines meet, so like there, there, and then up here. Each of those is a representation of a carbon. As long as you don't have anything else written there, each of those is a carbon. So here we have 1, 2, 3, 4 carbons connected. That stands for 1, 2, 3, 4 carbons connected. And you may already say, but wait, that last one is a double bond. Absolutely correct. That last one is a double bond. On the second carbon over, and you can number these as well over here, if that helps you keep things straight. On the second carbon, we also have a carbon that sticks up. So this is where you start when you're going from skeletal to expanded. What you want to do now that you have all the carbons that are there, is you want to begin adding in hydrogens. Now, remember, carbon bonds 4 times. That's just what it does. It bonds 4 times. And so if it's got 1 bond, you need 3 more, and those are going to be hydrogen. So as you see here off to the far left, I have 1 bond of that carbon. So I need to add 1, 2, 3 to give this carbon 4 bonds. You're just counting to 4. Up top, I have 1 bond to carbon. Now I put in 3 more. Okay, now it's done. Okay, so now we go to this guy. It currently has 3 bonds. So you only need 1 more, so it only gets 1 hydrogen. The next carbon over has 3 bonds. It only gets 1 hydrogen. Now if you drew that up top versus down below, it's the same thing, don't worry about it. The last one here has 2 bonds already, so it gets 2 more hydrogen. And again, if you put that in a different location, that's fine. So you have to go through this to get between either of those ends. That's why I put this in the middle when I'm drawing it out like that. So if we're trying to then go into the condensed structure, so the condensed structure is when you have things like CH3, CH2, that type of thing, okay? So there's a couple ways that we can do this. I'm going to start from the end and go CH3, and then to the next one over, CH, and then you've got to say up top is a CH3, and then we have a CH and a CH2. So you don't migrate things too far. You could also write this pretty easily as a CH3 and then 2 CH, CH, and CH2. Now, I wouldn't personally combine those 2 CHs. Why? Because they're different kinds of CHs. Let's just go with that, because theirs is all single bonds and this is double bonds. And that can get confusing when you're trying to go from the other direction. But these are options here. Now, the next one down, we have a ring. That may not look like a ring. It's supposed to be a square with something sticking off of it. Whenever you have a ring, you cannot do these condensed structures. So just don't worry about it. There are ways to do other types of representations there in typeset, but they're just not very good at it. So just like we did before, we want to identify. We have 1, 2, 3, 4 carbons in a ring, so that's a square, and then we also have 1 sticking off. So that's what you start with. I'm going to start with the 4 corners of the square and then connect them. And then I'm also going to put in another carbon there. So now we need to add in the hydrogens. So each of these carbons, well, not each of them, take that back. Some of these carbons in a ring, if there's nothing else attached to it, have 2 bonds already. And so since this carbon already has 2 bonds, I just add in 2 hydrogens. Now you may start to think, why aren't you putting those hydrogens in the middle of the ring? It's actually simple. There's no space for it to be in the ring. The molecule's not big enough. So now we come to this last carbon in the ring. It has 3 bonds already. It can only take 1 more. And finally, the last carbon that's over there, we have 1 bond, so it gets 3. This actually becomes sort of methodical and, a little bit more fun after a while. Okay, so now when we're starting in the middle, we can go either direction, but let's go ahead and do the first section here first. Okay, so we've got CH3 on the left. We then have CH2. We then have a C, and it's just a C. It is by itself. Sometimes that panics people. And so I'm going to point out something to you here to make life a little bit easier, I hope at least. You see here we have a CH3 there. We have a CH3 here. And we have a CH3 here. Which means that the easiest way, at least for me to say this, is to do a CH3, 3. Oh, I messed that up, didn't I? I'm sure you caught me. I accidentally took that guy out. And he's clearly still in there. Okay. So, going from the middle to the far right, I accidentally put in those highlights, and I'm not going to be able to take them out right now, so just bear with me, please. Here's what you do. I have 1 bond here, 2, 3, and then I've got something up and down on this guy. So I have a total of 1, 2, 3, 4 carbons in a chain. So I start by putting down, there's 1, 2, 3, 4 carbons in a chain. And then we have 2 more carbons coming off of that 3rd carbon. So that's this guy right here. And I'm going to put 1, 2 more. And again, you may ask, why did you do 2 towards the bottom? If you remember, these things are tetrahedral. And so you don't see carbons that are like this with another one in there. And that's just a stylistic type of thing. Don't worry about it. If you drew it the other direction, it's not a big deal. So just don't worry about it. So if you start to see this, they're the same structures. You just have to figure out how you're going to represent them. Excuse me. Thank you. So next, we can't do this again because we are not able to do that with a ring. So let's go ahead and draw our lines that represent our bonds. We have 1, 2, and if you want to overlay them, that's totally fine. We got something here, here. You see how these structures are related? We get a double bond here, okay? And so that's exactly what you're drawing over here. And there you go. That's pretty easy to go from the middle to either side, in my opinion, but it's harder when you're going from one side or the other. And speaking of harder, this is probably the hardest one to see, okay? So we're going to take things from the condensed structure and go over to the skeletal. Now, I don't know if you've sort of seen this, but a typical starting pattern or ending pattern is like a CH2, CH3. Like if you have a whole bunch of things together, it would be CH3, CH2, 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 CH3. Well, that's like just a standard 1, 2, 3, 4, 5 carbons. No double bonds, nothing else special coming off of it. So that's what you typically have. And you can kind of logically figure that out because this one would be on an end. It has 3 hydrogens because it only has one other bond. And the things that are in the middle have 2 bonds, so you can only have 2 hydrogens. That type of thing, right? So if you start off seeing a different pattern than that, like this CH2CH, that's telling you it is not that. So if I start looking at this and I just look at, okay, well, I know that my first carbon is going to connect to my second one in some way. And this has 2 hydrogens, 1, 2. And the next carbon has 1 hydrogen. And that's it. Well, I look at this and I think, what isn't there? Well, what isn't there is kind of simple. Sorry, I was trying to move that hydrogen over and I couldn't. And that is another bond. It's missing something. So both of them are missing something. Now this one is also going to be attached to a CH2 and then a CH3. So in this area, it feels kind of bare. Well, because it is. It's missing that other bond. So how can you tell if that happens? Well, you can tell that that happens when you get through drawing these out and 2 carbons that are next to each other, that they're both missing another bond. And so that would be a double bond. If you're missing 2 hydrogen or 2 bonds on both carbons, then that would be a triple bond. That gets serious though. Okay, so how do we go from one thing to the next? Well, we just made this all nice and straight, but there's a double bond there, there, and there. So we have 4 carbons. 1, 2, 3, 4. And between carbons 1 and 2, there's a double bond. I didn't draw that great, but oh, that was even worse. Let's try it right there. Okay. Okay. As I said, after a while you start to recognize patterns, and you may already recognize this pattern right here, where you have a CH3, 2 next to a CH. Well, what is that? That is where you have a single CH and there's 2 what I call ends coming off of it. So CH3s are on the end because they have to be. They can only bond to one other thing, right? And so that's telling me that this is sort of the pattern, because we have CH and then 2 CH3s, and then that can be connected to the rest of that molecule. Okay, so we have here now CH2, and then finally a Br. Now, this is the first time in this video, at least, we're seeing an atom that is not carbon and hydrogen. Okay, so we need to account for that for sure. We've got a bond here, 2, 3, and then we've also got a bond right here. So we actually have 4 carbons and 1 bromine that we're going to represent in our skeletal structure. So if you all haven't seen this yet, I sort of start with the longest carbon chain that's connected. And that's it. There's 1, 2, 3 carbons. And I draw that with the zigzags. And then I see, okay, well, on carbon number 2, I've got 1 more coming up. And then here's where I see some mistakes sometimes. We can't just put Br down here, because if I just do this, then what that says is I only have 1, 2, 3 total carbons now. That's not the case because remember, there's a fourth carbon up here. So we can't just do that. What we have to do is we have to still leave that carbon there, carbon number 3, 1, 2, 3. He's there, he already exists. You now need to write a new bond to the bromine. So don't forget about our new friend bromine. Okay? So I hope that helps get you started a little bit more with writing out different types of structures. Thank you very much.